Okay, hello. Okay, now you should see the desktop. Okay, okay. So everything is, can you hear me? Is everything seem to be working? Let me bring up the chat.
Yeah, I can hear you and see your screen.
Okay, great, thanks. Okay. Okay. Um, let's see. Um, the homework assignment was due already. Yeah, there'll be a new one up, hopefully by, over the weekend. I'll try to get a new one up there pretty soon. So there's going to be an assignment involving what we're going to start talking about, event programming and GUI programming. Okay, so we want to, okay, roughly what we're trying to do is, it's way down here. Here's render 2. Okay, all right. Render 2 lets you write things that are interactive. Okay, so you can write a program like this. The most interactive one is probably something like this one. Okay, so it shows you a model, but it's a keyboard controlled program. So to keep things simple, this window, you can't click on anything yet. So everything's done by keyboard commands. So if you want to move this to the left or the right, you use the X key. So X key adds and subtracts to the vertices and moves it left and right. And the Y key moves it up and down. So I use up and down is by Y and shift Y. Okay, so you can see here, it's lowercase x and uppercase X. Lowercase x moves to the left, uppercase X moves to the right, lowercase y moves down, and uppercase Y moves up. And then the Z letter, the lowercase z pushes you back, which is making you more negative, and uppercase Z moves you forward. Okay, all right. So the GUI is responding to keyboard events. Okay, and what that means is every time I tap a key, the program notices that, and it changes the vertices in the model and then re-renders the model. So there's just one model on the screen. It's got 4 vertices in it, and the model was rendered with the vertices in those locations. And if you want to know where the vertices are, you can turn on debugging in the, see, I hit the D key for turning on debugging, and I can see where the vertices are. The renderer tells me that I had 1, 2, 3, 4 vertices in camera coordinates, and this is where they are right now. And they projected to these, and then they got clipped and rasterized to, it rasterizes 1, 2, 3, 4 lines. See, there was 4 lines to rasterize. Okay. Then if you want to see that little menu again, you type H for help, and you get the little menu again. Okay, and every time I move, see, right now I have debugging turned on. So every time I tap a key like the X key, since that that goes and it modifies the model, you get them and then renders it again. The renderer shows you what it's doing again. Okay, so for example, here's my X coordinates. Okay, if you can see, they went from negative 0.81 to negative 0.82. Okay, and then I tap X again. Now it's at negative 0.83. My X coordinates are moving to the left 0.01 units. I'm subtracting 0.01 from each X coordinate. Okay, so that's what moving to the left does. Okay, and then you can see what pixels. Yeah, well, this isn't showing you the pixels because there's just too many of them. There is a mode in the debugger where you can actually have pixels turned on. I can't remember if I put a key command for it. No, there's no key command to turn. You have to recompile the program to get the pixels, but it'll show you all the pixels that it's painting here too. It'll log all the pixels over here, but that's an awful lot of information. So usually I don't even have that compiled in, but you could compile in that information so that when you turn on debugging, you actually see all the pixels. Okay, all right. And then there's this other key command that lets you change the model. Okay, it's the slash key cycles through the models. So there's just one of every model. Okay. And not sure. Oh, I forgot to turn on clipping. So what's going to happen here? Right now, it's trying to draw the next model. The next model slightly off the screen, and it's causing, because I forgot to turn on clipping, see, it's causing see that model was off the screen. So I should turn on clipping. Okay, now models won't do that. When the model went off the screen, it caused bad pixels because remember, if you go off to the left, you actually go down a row and come back in from the right. If you go off from the right, you actually go up a row and come back in from the left. That's because the actual pixel buffer is a one-dimensional row major row. But if you go off the top of the screen, if you go off the bottom of the screen, then you're going off of the actual array, and then you're getting coordinates in the pixel buffer that don't exist. Okay, and if I back off, see now I can see the whole thing. Okay. All right, so you can cycle through all these different models, and you can cycle through them. That's about I can cycle through them fast. Okay. Okay. All right. So the GUI is here. In this case, when you tap this key, it changes the model that it's showing in the frame buffer. So the scene has one model, but this key lets you change what model is in the scene. So this key updates the model in the scene. These other keys update the model itself. So there's one model in the scene, and the X key updates that model. Okay. And then I can switch to a different model. All right, so we want to see how we can do this. Yeah, how do we get an interactive render? As opposed to what we were doing before, was every time you rendered something, you had to save it to the hard drive to see it. The frame buffer held the pixels. The frame buffer had to be saved to the hard drive in a PPM file, and then some other program would show you the pixels in the PPM file. Now, what's actually happening now is the frame buffer is being handed off to the Java window. The frame buffer, instead of being saved to the hard drive, it's being passed to a part of the Java GUI system that'll take the frame buffer for us and paint it on the screen. And if we go back to the, okay, here's the render. In the frame buffer class, there's let me go back a minute. Let me clean the classes so you can read things better. So just delete all the class files. Okay. In the frame buffer class, in the frame buffer package, there's a new file. That file is a frame buffer panel. That's the link between the frame buffer and the GUI system. And we'll look at what's in there later on. It's not a long file. It's pretty short. It's not that much code, but lots of little one line, 4 lines, 1 line, 2 lines. Yeah, so there's all the methods are very short, simple little methods. 2-line method, 1-line method, 4-line method, 1-line method, another 1-line method, and a really big 4-line method. Okay, so it's a fairly simple class, and it ties the frame buffer to the Java GUI. So eventually we want to see, and we won't. The way it ties them together is tricky. It uses something called a memory image source, which we won't really worry about. What we're really more worried about is just the idea that you can tie our frame buffer to the GUI, and what we really are interested in is how we can make it respond to events. how do you make the program you're running respond to keyboard events or mouse clicking and things like that. So that's what we're really interested in. So we're not going to spend much time talking about this file here, but we'll spend a lot of time talking about how you can make the program interactive. This, from our point of view, this is just the thing that lets us pass a frame buffer to the GUI system, and then the frame buffer shows up in the GUI. Okay? All right. So what we're going to do is switch to talking about GUIs, though. So let's switch to over here in the web page. I have a zip file here with some simple examples, and you've got some reading. I gave you an introductory reading about GUIs that was this section 4.4. Okay, it's a nice little introduction to GUIs. And then later on in that book, they did a more detailed thing about GUIs. Okay, what we're interested in is the most is this, the Java event model. Okay, that's what your next homework assignment's going to be. The Java event model, and you'll use the renderer, but what really we want the renderer tied to events. Okay, so that's what but I think it's real important that you learn these other things. We could actually skip all this stuff. We don't actually, like, for example, the program I just ran doesn't use any Java GUI items, really, not much. I mean, notice it's really, this is the renderer just sitting in a window. It occupies the whole window. So I'm not really drawing a GUI, and I'm using keyboard commands to, so all the feedback that the GUI gives you is just showing up here in the console window. Okay, so I'm not making real use of the Java GUI system here, though we could make as much use of it as we want. And we'll play around. We'll make these things more GUI-like, but right now they don't feel very GUI-like. But this is a console window, so this is not GUI at all. The debugging information is all showing up in the console window, and all we have here is one frame buffer sitting in a window. Okay, so it's not especially GUI-like. There's no buttons, there's no scroll bars, menus, or anything like that. But we can add a little bit of them. We can add as much as we want of them. But this right now, this is just emphasizing the renderer. This other stuff is emphasizing Java GUI. It's got nothing to do with 3D rendering. It's how do you make GUIs like this? How do you make GUIs with tabs and menu items and little buttons and arrows and text fields? Like, how do you create elaborate GUIs? Well, you should learn a little bit about that. You should you should learn a little bit about GUIs. So we're going to talk, we're going to kind of go back and forth between basic GUI programming and using events to drive our renderer. Okay, so from the point of view of the 3D graphics, we only care about the events because the events let us drive this program. Okay, yeah. Here, the only thing I'm using are the events. In this case, the keyboard events. Okay, that's what I'm interested in, keyboard events. But you should see how to build GUIs too. Okay, how do you make a GUI? And that's got nothing to do with 3D graphics programming. GUI programming and graphics programming are not by means the same thing. There's no graphics mentioned in these sections here. It's all GUI. Now, this is a graphic thing. It's on your desktop, but it's not a 3D graphics. It's not. It's emphasis on information. The emphasis here is on mostly text information and possibly pictures also. Web pages, things like that. Okay, so, but you should see how that works. What's the basics of the GUI of programming? And Java, I've mentioned before, very few people use Java for GUI programming anymore. It's almost completely dead, but it's a very good GUI library. It's a good one to learn. There's a lot of older, in the 1990s and the aughts, people thought Java would be a big deal, so there was a lot written. And like, here's some other books. I've looked around the internet. Actually, these are all really good. Like, here's another introductory chapter on GUIs from, this is actually the book we taught CS123 out of for a long time. So this was the CS123 textbook, an introduction to Java. And it's got a nice little chapter on GUIs. Okay, actually, it's got 2 chapters on GUIs. And they made them available for free over the internet. That's actually the that's the publisher themselves made these 2 chapters available for free. Here's another book that I used this book last year to teach Java, CS123. And it also, for some reason, has the GUI chapter available for free over the internet. The book is called Building Java Programs. I don't know, maybe because GUI stuff is so out of, maybe they felt that they could just give it away for free because there's not that many people using it. But it's it's real good to learn Java GUIs because it's a well-designed GUI library. If you understand Java GUIs, you can do C# GUIs, Windows GUIs, Python GUIs. You know, you can do almost any kind of GUI you need if you understand Java ones. Okay, so there's another GUI chapter. There's a lot of overlap between these chapters, but there's also some of them present some ideas a little better than others. This is Oracle's main reference on learning GUIs. So this is the Java tutorial from Oracle, you know, and it's got tons of examples. You know, so this is their main section on documenting how to make GUIs. Okay, all right. So now download this zip file, and we got some code. I'm going to start looking at some code. Not graphics code, just GUI code. Okay. Oh, now over here, I linked to these chapters. In this folder, I just put them in the folder. Okay. Well, actually, I didn't put them in the folder. I just put links to them in the folder. Okay. So if you double click on that, you can download the chapters yourself if you want them. Okay. So I put links to the chapters in that folder, and a couple ones are linked to in here that I didn't put a link to on the website. Okay. So here's another chapter on GUIs. I didn't put a link to it on the website, but these are all introductory chapters on GUIs. This one's a good one, but it's a pirated one, so I didn't want to link to it on the website. That one's not supposed to be up on the internet, you know, but it's a very good chapter. Okay, it's from the famous book Java How to Program. Okay, I'm not sure why somebody at Murray State put it up on the internet. He put that. Well, I think he put two chapters up on the internet on GUIs, but they're not his to put up there. But they're there. Okay, and they're like, okay, this one is graphics. Actually, that's one reason I like this one, because the other one, this one is a chapter on GUIs, but this is actually Java's graphics, but 2D graphics, not 3D graphics. This is a little bit interesting if you're curious about what's the difference between graphics and GUIs. So this is the only one I could find that's an introduction to graphics, actually. Okay, so it's things like painting boxes and shapes. See if they get. Doesn't have very good examples, it seems. Things like fonts. Here, things like shapes. That's graphics, not GUI. Okay, shapes, ovals, shading in the shapes or not shading in the shapes, filling in regions. Yeah, it's starting to become more geometric. It isn't things you necessarily click on, but things you want to paint on a screen for some reason. So if there's things that you want to paint on a screen that aren't necessarily buttons and things you click on, that's more graphics. See things like this. Okay. So in the extreme, it's a program like Paint. Okay. This is GUI up here. This is graphics down here. Okay. This is the GUI stuff. You click on these things. That's GUI-like. Okay. But then you draw down here. So it's an extreme example of GUI versus graphics, but 2D graphics. Everything's 2D. Okay. So this one chapter is a little bit of an intro to Java's 2D graphics. Okay. And just like we need a GUI window before we can draw any, we need a GUI window to do our 3D graphics in. The same is true over here. You need to know how to create a GUI window, at least a window, before you can do any graphics in the window. So you need to do GUI, at least a GUI window before you can paint the graphics in the window. Okay, now, so in that folder, if you download that folder, I got a bunch of book chapters that you can look at. Okay, now here's an outline of here's an outline of GUIs. This outline is true for pretty much every GUI library I could think of. Now I'm talking here, I'm actually referring to, I'm using terminology of the Java GUI library, but essentially every GUI library is built out of 5 ideas. There's 5 main parts of the GUI framework, okay? Components are the things you click on. Now, see, there's components, containers, layout managers, events, and listeners. Okay, those are the 5 things. Okay, so then here under components, I give you examples of components. Under containers, these are examples of containers. Under layout managers, these are examples of layout managers. Under events, these are examples of events. And then under listeners, now all these names here are class names in the Java library. So there's a key listener class. There's a text event class, there's a grid layout class, there's a JWindow class, there's a JTab pane class. So these are Java names. Even this, see this word, okay, a component is a thing you click on. Component is the basic unit of a GUI. So you can look at what they're all, labels, text fields. Text fields are where you can type text. Like this window is just a big text field. You know, right here, this window here is a text field. This window here is a text field because I can type into it. Now, checkboxes. Oh, I'm sorry, checkbox. There's a checkbox right there. See, check. See, that's a checkbox. Button. Well, there's buttons, a lot of them. That's a all of these are buttons. Now, these are buttons in a bar, but every one of them is a button. Okay. And those buttons are in, oh, I didn't put it in here. Java has a toolbar, okay? So I could have put here, I should have put, there's J toolbar. That's one of the components, J toolbar. So in Java, you can arrange buttons in a row like that, and that, you know, people tend to call these toolbars, and Java has a Java toolbar, J toolbar, that you can put buttons in. Okay, what else? Let's see. Combo box. I don't see one on. Oh, let's see. No, I don't see a combo box on here. List. That's this. This is a list over here. These items are in a list. Scroll bars are all over the place. See, there's a scroll bar. Okay. Slider. Don't have one on this page. Sliders are not that common, so I don't even know if I would find a slider anywhere in TextPad. Tabbed pane. Well, these are tabbed panes. Okay, this is a tabbed pane, and in this tab pane is a big text field. Okay, choice. Oh, I can't remember what Java calls a choice. I don't remember if that's what people call radio buttons. I forget what Java calls a choice. Okay. Now, if you do something like you go under configure preferences, you see a more elaborate GUI. You see things like check tree component. See, all these things are called components. This would be a tree component, something that lets you show a tree structure. Okay, so now Java has one of these also. This one is Windows. These are Windows components here because this is a Windows program. So when everybody has the same kind of thing, so Windows has all of these component items, and here we're seeing more elaborate ones. Like, well, there's a ton of checkboxes, bunch of buttons. This would be a tree control, a tree component. See if we see any others. Okay, see over here. Radio button. That's a good one. So you notice you can't click both those buttons. You can only click that one or that one. That's called a radio button. If you click one, it unclicks the other. Okay, so that's I didn't put that. I should have put that in the list too, because radio buttons are pretty common. Okay, that might be that might be what they call choice over here. You make a choice between this and this. Okay, that might be, I can't remember. Most people call these things radio buttons because of the old-fashioned car radios well, even in a modern radio, when you think of, you select the station by pressing a button. When you press button 4, you go to station 4, which takes you away from whatever station you were at. So yeah, they tended to call these things radio buttons. Okay. So components are the things you click on. Now, component is a Java word. In other worlds, they call these things widgets. They call them controls. Widgets is what Unix people tend to call them, widgets. Like if I Google the word widget, well, you should also spell it right. Notice it shows a picture of a GUI. Yeah. So I didn't know iOS used the word widgets. Okay. Now, the word widget actually goes back a long way. It meant something that's like a placeholder name for an unnamed, unspecified, hypothetical thing. Yeah. In computing, see, widget GUI. Okay. In GUI land, the word widget means these things. See, they show you widgets. You see, they're showing you all different kinds of widgets. Yeah. So if you're in Java, people call these things are called components in Java world, but Linux people call them widgets. So the Wikipedia page for GUI widgets is showing you widgets. I mean, you can't even tell if those are Java widgets or not. They're probably not Java. Well, they probably were created by some Linux program. Okay. So those are the things you click on. Now, Microsoft calls them controls. So if I Google controls, I'm not sure. Okay. A control is a child window that an application uses in conjunction with another window. Okay. So we're going to see that these components all sit inside of containers. So that's what they mean. Components you cannot have a button by itself. You can't have a floating button on your desktop. Components are always, we're going to see, placed inside of containers. Okay. So here, a control is a child window. So it's something that sits inside of a window, which are our components. Okay. So what's a control library? A library of a bunch of different widgets. If somewhere you can get a nice picture of, see, here's, they just show you different pictures, different controls. Notice that they're showing us the same thing: check boxes, buttons, here little tree displays. You know, these are examples of controls. Okay, Microsoft calls them controls because you control your GUI through these things. Okay, so the terminology here is all over the place. Yeah, so components is Java's word for them. Widgets is Linux's word for them. Controls is Microsoft's word for them. Okay, these are the things you click on. You can't have them sitting on a desktop by themselves. They must be placed in containers. Okay, so now Java there's way more components than I've listed here. There's tons of different components. There's actually only a small number of containers. You don't need a lot of these things. Okay, so for the most part, we're going to only use these two. This is the top level container. This is the window you see on your desktop. Okay, a top level container is that. A top level container is this. Okay, that's a top level container. Those in Java, they're called J frames. Okay, then inside of J frames, you can put sub containers that are used for organizing things. So like here's the idea is going to be like this. This container is a J window, J frame. It can actually hold only one thing. Okay, If you want to put two things in it, you have to somehow group them. It's a little bit like an if statement. You know, if you think about an if statement, if something, you can put a statement here, semicolon. What if you want a second statement? Can you put a second statement in an if statement? You know, can you put two statements in an if statement in Java? What do you have to?
Yes.
No, you can't. You can't. What do you have to do?
Bracket.
You have to put them in a. You have to put them in a group somehow. They have to be put into a. What's the right word for that? I forget what the brackets are called. A block statement. You have to put them. You can't put two statements in an if. You have to put the. You have to. You have to put one thing in an if, but that one thing can be a block. Now there's only one thing in the if, but we call it a block statement. It's a container for multiple statements. Java GUIs are the same way. The J-frame only can hold one thing. You could put one button in a J-frame, not two buttons. If you want to put two buttons in there, you got to put something in the J-frame that can group multiple things. That's what the panels are for. So the panels, like the braces, the block. Okay, so this is not allowed, and you can't have two statements in an if because Java only by definition allows one statement there. But the statement can be a block statement. And if it's a block statement, blocks can hold multiple statements. Same with, so that's how they organize it. That's a very common organizational way of designing anything. Okay, it turns out to be what you're separating is the idea of holding from the idea of holding multiple things. Your top level thing holds something, but that's only its job. The top level thing is only responsible for holding one thing. Then you give somebody else the responsibility of holding multiple things. So the top level thing only knows how to hold one thing. That's its concern. Its only concern is holding one thing at the top level. The main job of if is to decide whether you should take the, see, think of it. The main job of if is really to do branching. So his concern is, do you do this guy or this guy? His concern shouldn't be, oh, and I have to worry about how many things I have to group. You may have heard of the phrase separation of concerns, okay? So if's only concern is, do I do this one thing or I do this one thing? But then I want to be able to put two things in there. So I give somebody else that concern. The block statement has the job of grouping multiple things. It has that duty. So now if says, oh, if this is true, you do this block statement. And then the block statement's worried about whether there's multiple statements or not. Very common design strategy, separate concerns. So one thing, here the if is concerned about one thing, the brace is concerned about something else. Together, they give you what you want. Well, they did the same thing in Java. J-frames can only hold one thing, but their concern is things like minimizing and maximizing and closing. This is the frame up here. Its actual concern is mostly minimizing, maximizing, and closing. Okay? So if I click that button, see, it closes it. Okay? So the frame is at the top, and its real concern is it's the thing you move. So it's got that concern. It's got the positioning concern. It's got the size concern, and it's got the ability to maximize, minimize, and close. Then if you want to put one single thing in it, like the Java GUI the graphics GUI I just closed only had one thing in the J-frame. Okay. If you want to put more, like if you want two buttons, you need something to hold the buttons. That's the container panel. So the JFrames, the top level container, which is almost always the window you see on your screen. And then if there's more than one item in that window, the items are really grouped into panels, okay? And then panels can hold panels can hold panels. And then you use panels for organizing your GUI, okay? So then you can, just like over here, just like here, there's nothing to stop you from organizing your code more here. Yeah, you can have blocks within inside blocks. And you don't even have to have if statements or while statements. You can have blocks within blocks, okay? Does anybody remember why would you do a block within a block without there being an if or a while or a for here?
Scoping?
Yeah.
Yeah.
So you could declare a variable here that isn't that would be gone when you get down here. So if you declare a variable here, int x, that x is alive in that block, and that x is gone by the time you get to down there. So it's used not very often, but if you did want to scope a variable to just a part of the block, you use braces. So one of the things, one of the responsibility of the braces is to control scopes, okay? So the brace has actually got two main responsibilities. It lumps multiple statements together, but it also determines scopes. So a variable declared in this block only lives inside that block. So the brace has really two main responsibilities, and the if has just one responsibility: evaluate that Boolean and decide whether to execute the then part or the else part. Okay, and as far as it's concerned, the then part's always just one thing. Though for our point of view, it's almost always one block. Okay, so that's a real common design pattern, and most GUI systems use it. They have a top level container, and they have, now you don't need, notice that you don't need, well, over here you do need a little bit more grouping. So you have like parentheses. Okay, so parentheses do a little bit of grouping. Here, there's only really needs to be two levels of grouping: frames at the top level, then panels. Panels can hold panels, can hold panels, can hold panels. There are J windows. I don't even remember what they're used for. I have to look up. I forgot what J windows are used for. And applets don't exist. I thought I deleted that. I meant to delete that. Applets kind of are obsolete. Applets were supposed to be windows in web pages. An applet was a Java window, a Java container in a HTML web page. You're not allowed to do it anymore. They had so many problems with those things. They were so buggy and so have so many security problems that the idea that you would put a Java window in an HTML page, it was real common for a while, lasted about 5 or 10 years. Then finally, everybody pulled the plug on it because it was just there were too many security problems with it. And that's when JavaScript started really taking over. With the death of applets, JavaScript started taking over what Java had been doing for a while, but Java didn't do it very well. So these you can't use them anymore. Every once in a while you see a page that has you'll see a web, if you look at old university websites, you see a lot of pages with big blank spots, and a lot of times they're applets that won't run anymore. You know, there's thousands of them left on the internet, applets that people wrote 20 years ago. The browser won't run them anymore. Okay? So this one's obsolete. So that leaves really just JFrames, JPanels, and JWindows. And I don't actually remember what a JWindow does in Java, because I only ever use JFrames and JPanels. I think it's another kind of top level. I think I have to look it up. I think it's a different kind of top level container. Okay, but so there's really, from our point of view, going to be two levels of containers: JFrames and JPanels. Okay, so these are the things you click on. Oh, you don't see these. Well, you see the top level one because it's got the bar up here, it's got the little buttons here, and it's got the edges. You don't see JPanels. They are invisible to you. If a window's got 4 JPanels, unless somebody colored them differently, like gave them each one a different background color, you wouldn't see them. Like this window is probably a whole bunch of panels. My guess is this window is one panel for the text editing. I'll bet that this whole region up here is probably a panel, and this is going to be a panel, and there's probably another panel down here for the status bar. So this window is very likely 1, 2, 3, 4, at least 4 panels. But then this panel's probably sub-panels, like each one of these rows is probably a sub-panel of that panel. Or it could be that instead of there being one panel that holds these 3 rows, it could be that this window holds a panel for this row, and a panel for this row. You can't actually tell very easily, okay? Unless you look at the code, you don't see panels. They let the programmer organize the GUI, but unless the programmer does something like give them all different background colors, you really can't see where their borders are. Let me show you. Let me see if I can real quickly find this. Let me see if I remember where it is. I had a program on my computer that I forgot to put a link to it on my desktop here. Okay. This is a weird little Windows program. Lets you examine GUIs and ask what their panels are. See how it's outlining things on the left? And it's giving me information. Here, look. This is because TextPad's a Windows program. This is a Windows program, and this is a thing called WinSpy. See the class here? That's the name of the panel. Now, if I click on this guy and I move it, see, that's an editor window. That's something called a client window. That's a toolbar window. That's another toolbar. Oh, see, this toolbar is different from this toolbar. So there's 2 toolbars next to each other. That one is a rich text field. Okay, that one's a rich text field. What's this one? A list box. See? So yeah, now none of them are showing up as panels. So actually, it's not, even this guy's not showing me the panels. It's showing me the controls. It's telling me what every control is. Okay. So, Windows, programmers need to debug things. Sometimes programmers will have a GUI and they're not sure what's really going on in their GUI. So there's these weird little tools you can download this one's from Microsoft, if I remember right. I think that one's written by, that one's part of Visual Studio, if I remember right. Here's another one. Same kind of idea. It kind of outlines the thing and it tells you what it is. Okay. So it gives you a sense of the structure. It's used to debug GUIs to get a sense of the structure of the GUI as it appears on the screen. Because how it appears on the screen should, you wrote the code, but if your code's got a mistake in it, you may not have showing on the screen what you thought you did. So you use these kind of programs, these called Windows pickers, to let you look at your windows. See, there's a whole bunch of them. Over the years, I've downloaded a bunch of different ones from different places. And so if you Google like window picker, you can probably find these. Most of them are kind of old. I think this is a more modern one. Okay. But the GUI is built up out of a ton of different sub things. Also, there's the panel that's at the bottom, and it's a status bar. It's actually called a status bar. So there's an XTP status bar class somewhere in Windows. Okay. Okay. All right. So that's components and containers. That's the GUI. Okay. Oh, well, actually, there's one more. There's the GUI needs one more thing. When you put multiple components in a container, somebody has to figure out how are they laid out in the container. Like if I put 2 buttons in a container, are they going to be next to each other? Is one are they going to be stacked vertically? Are they going to be stacked horizontally? This is called the layout. Now, the way this works is each container has a layout manager that decides how things are put in the container. When you put multiple things in the container, we'll see in a minute there's something called the border layout, flow layout, grid layout, card layout, and grid bag layout. I think there's a few others, but these are the most common, these 5. They are things that determine how the components placed into the panel are placed. How are they laid out? Okay. Let me show you a little program I wrote that demos this. See if I can. Okay, let me run this. Okay, here's a GUI. Doesn't do anything. You click on the buttons all you want, they won't do anything. Okay. The structure of this GUI is a window, an outer window, holding a container, and that container has something called the container has something called the border layout. It's called the border layout because the panel's divided into 5 regions: north, south, east, west, and center. Okay, so you don't see it, but there's actually 5 regions in this GUI: the north region, the south region, the east, west region, and the center region. Okay, now what I've done in the program is that the north region, I put 1 button in it, and the button takes up the whole region because that region doesn't have its own, it's a container that only holds 1 thing actually. So it's holding a button. This one's holding a label, west is holding another label, and south is holding a button. Now in the center, I put another container. I put a J panel in the center, then I put 4 buttons in the J panel. Watch what happens when I shrink this. Notice that there wasn't enough room for the buttons to be on side by side, so the buttons flowed. The buttons flowed down. That's the flow layout. So what I have is, I have 2 panels, one inside the other. Oh, I have a frame holding a panel. The outer panel is using the border layout. It's called border layout because it's got 4 regions along the border: north border, south border, east border, west border. And it's got a central region. But then I put another panel in the center region, and I gave it the flow layout. The flow layout is called that because of like text. You know, when you do this, what should happen when I get to the edge of the screen? Well, what's TextPad doing right now? What are the 2 choices?
It's scrolling right now.
It's scrolling. What is the other choice?
You can make it wrap around or
Right. And that's called, sometimes people call that flow. The other word for wrapping, see, everyone's got more than 1 word for every idea in computer science. This button here wraps it. Word wrap. Java doesn't call that wrapping. Java calls it flowing. And a lot of people refer to it as text flowing. So if you Google that, text flow, this idea that you could flow text. And text flow is also called text wrapping. I was wondering to see if somebody would say that the text flow and wrapping are the same word. Yeah, what like TextPad, see, the button is wrap. See, now it's scrolling, now it's wrapping. Okay, notice that, see now watch, see how the reason it's called flow, because see how it kind of just flows as the windows shrink, it needs to scrunch things into more lines. That's what's happening over here. As the window shrinks, first label 4 wraps, then label 3 wraps, then notice how it wrapped hello 4 and label 3 on the line 2 and label 4 on line 4. Now it has all, now it wrapped them. See, for button 3, hello 4, label 3, label 4. Okay, so that's, now I could have put a border layout inside of that panel. So I'm using 2 different layout managers. In the outer pane, no matter what I do, it's always going to have north, south, west, and east. And it doesn't matter how I size it, it's going to have north, south, west, and east. But this inner one, it's got 4 things in it in a flow, and as long as it can fit them on one line, it fits them on one line, so it doesn't care how big this is. But if I make it narrower, the flow layout, at some point when there's not enough width, the flow layout starts using multiple lines. Okay, that's a layout manager. My program doesn't have to think about that. By using a layout manager, I write a program that just says, create a panel and put 4 things in it and give it the flow layout. Then the program behaves that way. And I don't need to worry about how, I didn't write the code. When this thing flows, that's not my code that's doing it. I get that for free. Okay? So I get for free that thing is flowing because I'm using the flow layout manager. And I get for free that this button stays up here and this button stays down here, no matter what somebody does to this window. Okay. Now having a button stretch across the top of a window is dumb, but yeah, so I really wouldn't do this here. Okay. But the idea is that the border layout gives me 4 regions. I can put something up in this region, something in that region. Usually you put a panel in this region and then put things inside the panel. Usually you would put a panel down here and then put things inside the panel. Okay, now look at the code, how that works. Everything is an object, okay? So I create a J-frame object. Now there I'm creating a top level window. That's gonna be my starting point, my top level window, okay? So I create my top level window, okay? Now this is my main method, okay? So I create a top level window and I give it a little name that shows up that'll show up in the title bar, okay? Then I do some things. I can make it visible or invisible. I can change its size. Okay. Then I get to, so this is just playing around. Okay. Then I get down here with, I create a button object and I create another button object. Okay. Now creating buttons doesn't do anything. This creates an object in the heap. It doesn't do anything to the GUI yet. When you create a button object, you have just created an object in the heap. You have to tell Java that you want that button object to actually represent a button item in a GUI. You do that by adding the button to a container. That's you have to add that button to some container that's being shown. Okay, so create a button with that text on it. Create another button with that text on it. Here I create a container. Well, actually, I don't actually create a container. I get a container from the J-frame. The J-frame is like an if statement. It's a top level thing. It can only hold one thing. And what Java does is it's by default holding something called a content pane, which can hold multiple things. So I have to ask for the container of the J-frame. The J-frame comes holding one big container, and I need to get that container. Then I can add my buttons to the container. Okay? Now that container is using the border layout, so I say add that button using in the south and add this button in the north. Okay. Now the fact that the J-frame has a single container that uses border layout is something you find out by reading the documentation. Java defined their top level window to be one container. It's a window holding a single container. You get that container by saying get content pane, and that container is using a border layout. You can change that layout if you want, but by default, it's a border layout. So I put something in the north and the south. I create 2 labels. Again, I'm just creating objects in the heap here. That doesn't put them on, actually even, oh, this does not display them yet. Well, no, I'm sorry, it does. Yes, it does. Yeah, as soon as I add, since this, when you create the J frame, that's an object in the heap. As soon as you set it visible, you can see it. Okay, so that does not make it visible. That just creates an object in the heap. Tell Java to make it visible. Okay, tell Java to make it visible, then you can see it. As soon as you add something to a visible window, the thing you added becomes visible. So when I add this to that container, it should show up. And when I add this to that container, as long as that window's showing up, those buttons should start showing up. Then I add that, but creating the object doesn't make anything show up. So that creates an object in the heap, but now you tell Java, add to that container that object using in the east region of the border layout, and add to that container that component in the west region of the border layout. And then I just change the size of it for the heck of it. Okay. All right. So now I've got, that would have built this GUI with that button, that label, and an empty spot inside. There's nothing in the center of it yet. Okay. Then I go down here and say, oh, now give me a panel. I create a panel object. Okay. Now the panel lets me group things. Okay. Now notice that I commented out a line where I gave the panel the border layout. By default, the panel has the flow layout. The container in a J-frame by default has border layout. The panel by default has the flow layout. Those were Java's choices. A J-frame by default is a border layout, and a panel by default is a flow layout. But you can change these guys. So when I instantiate the panel, I could say, but I want it with that layout instead of the flow layout. So you can, the program will recompile the program. You'll see it'll act differently when I give it a different layout manager. Okay, create 2 more buttons. Now add the buttons to the panel. The panel hasn't been added to the GUI yet. So when you add the buttons to the panel, you don't see anything because the panel actually hasn't been added to the GUI yet. So that would add, oh, and then notice that I'm using the flow layout, but I put this in here. Java ignores this because that'll be useful when it's a border layout. But right now it's not a border layout. So when I add that button to that panel, Java says you're not using a border layout. So it doesn't give you an error, it just ignores that. Okay. So it's kind of quirky. I left it there because it'll be useful when the border layout's in use. Right now it's just being ignored because there is no north, south, east, and west when you're using flow. So add the buttons to the panel, create 2 labels, add the labels to the panel. Now the order matters here because in the flow layout, they appear in the order they were created. This was created first, second, third, fourth. If I change the order of change the order of adding them, it's a list. What I'm really doing is it's creating a list of GUI items. If I change the order that they're added to this list, then they'll appear differently over here. In fact, I could do that real quick. I could just create all 4 of them and then add them in any order I want. So right now I'm adding button, label, button, label. If I compile that, run it, button, label, button, label. Okay. So now it's got a different, see, now it's in the order, now notice that in the border layout, he's over here because he's put on the east or on the west. And he's up here because he's put on in the north. So it didn't have anything to do with what order I put them in. If I put him in the north, it doesn't matter if I put him in there before I put him in the south. Order doesn't matter. In the flow layout, order matters. They're flowed in the order they were put in to the control. He was put first, second, third, fourth, but over here, he was put in first, second, third, fourth. So adding items to a flow layout, order matters. adding items to a border layout, order doesn't matter. Okay. All right. So back over here. Okay. So far, where are we? Down here. I'm sorry. So far, we've been adding things to the panel. Then we need to add the panel to the J-frame in the center. Okay. Without that line there, all the stuff we added to the panel doesn't matter because the panel wasn't put in a top level window. So the panel, you cannot show a panel by itself. That's impossible. Java has no way of displaying a panel on a window. The only way a panel can show up is if the panel's put in a J-frame. Has to be put into a top level window. So these guys and all of these guys must appear inside of one of these guys. A program can have two of these guys. That's just a multi-windowed program. That style of programming died. Macs still use it a little bit. Some programs have multiple windows. There are occasionally people write programs with multiple windows. It turned out to be confusing as heck. Most people don't like them, but Apple's use them fairly often. Windows rarely ever use them. Java lets you do them. Your program can create multiple J-frames. So your program can have multiple top-level windows. But it's probably pretty frowned upon these days. Okay. TextPad has a kind of a thing like that. You know, if you compile this, you can tear off that thing. But this is weird. This is not two top-level windows. Yeah, this is not a top-level window. This is a floating window. Java, I don't even remember if Java has this or not. This is a more advanced GUI feature. Okay, this is not really two windows. See, notice, well, see if I minimize the outer one, see it minimizes both of them. They're not independent windows. And every time I do anything with this one, the outer one says, well, where do you want me to dock you? These are what people call docking windows. And I forget how to dock it back. There. Now I docked it back where it belongs. Okay, that's a much more advanced GUI component. That's actually, this thing is not a top level window. It's actually a very fancy GUI component. So it would be a component that can appear sort of its own separate window. So that's a real advanced. People call these floating windows or tearaway windows. They have various names for them. And I always forget how to get it back in the right place. There, okay? Notice how much there is to GUIs. There's lots of little weird things in GUIs. Playing around with them can be kind of fun, okay? Now go back to the code. When I add that panel to the J-frame, then it becomes everything in that panel will suddenly become visible. Okay, everything in that panel would become visible. Okay, now let's change this guy from float. Now we got two versions of them right now. Both these versions are using flow in the center panel. Okay? They're both using flow in the center panel. Okay. Now let me use border layout in the center panel. So I'll comment out this constructor and put back, so now I'm saying build me a J panel, but give it a border layout. Okay, compile this, run it. Confusing, but I've got a border layout and a border layout. There's see those two labels? Label 2 is in the outer border layout. Label 4 is in the inner border layout. The inner border center goes from here down to here, across here, up to here, and across. That's and then this border layout has a center with nothing in it. I probably should have put something in the center of this border layout too. But so there's nothing in the center of the border layout of the J panel. The J panel's border layout Notice I put something in southeast, northwest. Oh, I did put something in center. Oh, no, that's the center of the J panel, of the J frame. See, I never added anything to the center of the J panel. Okay, I could, let's see, J panel dot add new J button.
I have a question.
Mm-hmm.
Do any of these layout components allow you to specify XY coordinates where you want
Yeah,
to put
yes,
the
yeah.
components?
The ones I'm showing you now are the ones that are trying to avoid that. They're specific. The idea is that's actually turns out to be brutally difficult to do. And that's the grid layout, I think, is the one that lets you specify, you think of there being a grid. I can't remember if it's grid layout or grid bag layout, or if it's, maybe I didn't even put it in this list. There is one of them that lets you say, I want this component at the 47th pixel on the left, go 47 pixels down and 57 pixels over. Turns out that's a bad idea. Well, as we talk about these some more, you'll see that that turns out to be not a good idea. But I can't, it may not even be one of these layout managers. I think these are all the ones that avoid pixel coordinates. Okay,
I
but there
think you have
are,
to.
pardon me?
I think you have to turn the manager off.
Pardon me?
I think you have to turn the layout manager off before you can do that.
Well, I think it's both ways. You can turn off the layout manager and do everything yourself, but I think there is a layout manager that lets you also specify X, Y coordinates. So I think it's both ways. I think it's both ways. Okay, now let me add a button. I'm just going to create a button on the fly and put it in border layout dot center, and that's going to be the center of the. I'm putting in the center of the J panel. Okay, so there should be and it should fill up the whole center. Let's see. Did I misspell something? Oh, there's the constructor. I forgot to close the constructor. I need a new button. Oh, and then I put these parentheses in the wrong place. Okay, so I'm just creating a button on the fly. I didn't give it a name. I just created a button on the fly. Okay. See, there's that center now filled with one great big button. These buttons, now we haven't talked about the next stage. The next stage is events. So over here in the outline, what we've talked about so far is the GUI stuff. Components are things you click on that you see in your window. They have to sit inside of containers, but containers need to lay the components out somehow. So you have layout managers that make it more or less easy for you to lay things out. These are essentially, you might call these automatic layout managers. They lay things out for you in an automatic way. If you wanted to, you could lay things out yourself by putting things at XY coordinates. The beauty of this is the program, the program will do, you see the program resizes itself pretty well. Over here, the program, if that's what I want, this gives me what I want automatically. Okay. Oh, like look at TextPad. Watch what happens when I scrunch. See, now look at the top. See, look at the top menu bar. What did it do? Here, what's the right word? What did that menu bar do?
Can you do it again?
Nothing's showing.
What?
Oh,
Your
yeah, it
screen
just popped
froze.
up just now.
Really?
Yeah.
Oh, God knows what. Yeah, I should look at the movie afterward to figure out what's going on. What did the whole desktop go blank?
No, it just didn't show what you were seeing on your screen until like 5 or 6 seconds later.
So there was some kind of lag there, huh?
Yeah.
Oh,
it
probably
happened
there was
too.
some kind of lag then.
That's the second time it happened.
Yeah, when you were
so
doing
that
the
was
flow, yeah.
yeah. Now watch this top menu bar. Whoop. Watch this top menu bar. What's it doing?
Uh-oh, might have happened.
Yeah,
It's
lagged
lagging for
again.
me too. I don't think it likes you when you resize windows.
Wow. Damn. Okay. Wait a minute. Let me try something. You see it now?
Not yet.
No.
There it went. Something just happened. Were you messing with
Yeah,
the
I clicked on the
bar?
title. I clicked on the title bar.
Oh.
Okay. Tell me when it disappears.
I just see two, like the arrow for moving the pane to the right. It's
Yeah.
not doing anything though at the moment.
Oh, see, my screen's continuously updating.
Oh no, we're not catching any of that.
Okay.
The layout, yeah, now something just happened.
Okay, you
Yeah.
see it? Watch the menu bar.
Okay. It shrank that time. The everything's still there in the menu bar.
Yeah, but what did it do?
Oh,
It's
now it
hiding.
pushed them down to the row
Well, what's
below
the
it.
word? What word is programmer? You
flow?
call that what?
Word wrapping or flowing.
Flow?
Flow or wrap? Yeah, some people call some people will say the menu wrapped, and some people say the menu flowed. Okay, in Java lingo, it's flow. See, they're using a flow layout manager on their menu bar. Even though this is not Java, this is Windows. But see, they're not positioning. I can guarantee you, whoever wrote the code did not position these menu items. They're in a flow layout manager, so that they don't have to worry about writing all the detailed code. They would say, oh, when the menu bar, when this window button is too far over here, make it go down over here. That's being done by a layout manager. Okay, now let's see. Let me keep scrunching.
What if you set the location relative to the size of the frame?
I'm not sure what you mean. Say again.
Like set the location relative to the size of the frame
Set location of what?
of the components.
Yeah, you can. Yes, yeah. That's better than pixels. Yes, you can use relative positioning. Yes. Okay. Now this is flow, but then there is also what's called relative positioning, which is sort of like what this is doing. This is relative. This stays in the center, and this stays on the left edge, and this stays on the right edge, and this stays on the top. So this is an example of relative positioning. And then you can do things like, you can say, I want it to be halfway down and on the left edge. Or I want it to be halfway down and 3/4 of the way to the right, always. Always, no matter how big the window is, I want my button to be halfway down and 3/4 of the way to the right. So you can do relative layout. There's all kinds of different ways you can do this. These layout managers are the easiest automatic way to do things, and then there are more complicated ways. There's combinations of automatic layout with manual layout, and then there's purely manual layout where you just say, put this thing at pixel 2752, and put this other thing at pixel 1024. Very few people do completely manual layout. It's ridiculously hard to do, okay? All right, so what we've talked about is this stuff. GUI, components, containers, and layout managers. And we've seen an example of that. Okay. Let me show you kind of a cute example. I downloaded this from, real quick, I downloaded this from Oracle's website, but it's a nice example. The code's pretty straightforward. Okay. Click the buttons. See, this has got event. Click the buttons. But look, see, watch what happens when I shrink this. See, it's got an automatically pop-up scroll bar. Okay, that's kind of nice. See, automatically popping up scroll bar. These are called scroll panels. So, see, the scroll bar went away automatically, and then the scroll bar, I didn't have to write the code for that. This is kind of neat. I did not write the code for that scroll bar. It's done for me automatically. This is a very nice, sophisticated GUI component. It's a GUI component that will add subcomponents for you automatically. So that scroll bar appears automatically without me having to code it. Okay, so this is called a scroll panel. And then this is a little toolbar. This is an example of a little toolbar in Java. Okay, right. And so this is a simple little GUI, and it doesn't take that much code. You can look at the code of it. I took the code from their website, and they over-engineer the heck out of everything. Let me just show you what. This is my version. This is their version. They over-engineer everything. So their version is like twice as complicated. See, I tried to simplify it. Okay, so so this is a simplified version of their version, and GUI programming is like every other kind of programming. You learn by looking at other people's code. You read people's code, look at their examples. So, like the Java website for this GUI stuff is really, what it really is, it's a website of hundreds of examples, and you learn by downloading their examples and playing with them. And so you'll learn here by downloading the examples I give you, like this one here. Play with this. Move these things around. Try to add more buttons. Try to play around with this thing. Comment out something, see what happens. Okay? And yeah, the other thing you can do is you can open up Dr. Java. I was going to do that. We ran out of time, but you can open up Dr. Java. And remember I said that the items will appear when you add them. Well, if you do this in Dr. Java and you type code one line at a time, you can see things appear and disappear. You know, if you use the Dr. Java interactions window, you can just copy and paste this code one line at a time. A little bit tedious, but it's real informative. To copy and paste this code one line at a time into the interact and actually see the GUI pop up, and then the GUI change size. Then a button appears in the GUI. Then you can make the button disappear from the GUI. So these things don't all happen at once, because here they're happening super fast because they're running on the computer. But if you can see that each line of code, like this panel won't show up until you add it, and then all of a sudden the panel and everything in it will show up when you add it. Okay, so we've run out of time. Anybody have any last second question? Anybody have a last minute question? Play with these examples. Yeah.
Curious about the exam.
Uh-huh. Oh, I forgot about that. Let me see.
I think you said it's the 20th on the syllabus.
Of October, right?
Yeah.
So that would be 3 weeks. Well, yeah, it was two. Yeah, so it's a couple weeks from now. Yeah, I have to start. I actually hadn't started planning what's going to be on it yet. Okay, so I'll try to put up in a few days something that gives you an outline of what you should expect on it. It'll be mostly about projection, rasterization. You know what we've been talking about: projection, the algorithms. Well, the structure of model. You know, what's a line segment? What's a vertex? The exam will be things like, how can you build a little model for me? You know, can you write the code that builds a little model? Can you do I'll ask you to do the calculation of what a point projects to. If I say this vertex, what pixel will this vertex end up on? You can actually do that calculation. So I can give you a vertex and say, what pixel does it light up? So we'll talk about, but that's a good point. Bring that up. Remind me about that. I'll give you some review stuff and give you a sense of what kind of questions I want to ask you. But it'll be things like, can you show me you can build a model, show me you know what a line segment is in a vertex, and be able to do the calculations of, here's a vertex, what does it project to? What pixel does it land on? What pixel does it actually light up in the frame buffer? Okay, so that'll be what the exam is like. And keep reminding me. I need to put that review material up because I want it up there, but I would like to have it up there like 2 weeks before the exam date. Okay.
Cool. Thanks.
Okay. All right. Any other question before we quit? Okay. So, and I have to figure. I wonder what's going on with you guys not seeing the GUI. That's really. I have to look at the video and see if I can sort out what was going on there. Okay. So I'll go ahead and I'm going to stop sharing, and I'll go ahead and end the meeting. And have a good weekend. Bye.